Cool. Yeah, thanks. So, hi, I'm VT. I'm a developer, a technologist, a podcaster now, I guess. Um, uh, you know, During the day, I'm CTO at Lead Home Properties, which is a scale up that's using technology to sell houses. And after hours, I co-host a community or co-run a community called ZA Tech Radio. We've got a podcast that we try to release every Thursday. Every second Thursday. We are having some technical difficulties right now, but we also have Twitter Spaces that we host. We also have a Discord, and if you reach out to me on Twitter, you can get access to all of that. Like I said, I'm a technologist, right? So I like to write code. I'm not a master of anything, but play around a lot in the cloud with mobile, with APIs and all sorts of things. So that's it about me. Cool. I think we've all had this, right? Managing IT infrastructure can be expensive, right? It can also be very hard, and it can be inefficient. We've all experienced this. It's easy to get started with an application, hello world, Spring Boot, JavaScript, whatever, Bob's your uncle, and in today's world you've got Docker. But when it comes to deploying, it's always a pain. If you've worked in one of the corporates in South Africa, you know that it was on-prem, but everyone now has this new move. So they say, you know what, you should just move to the cloud, right? Almost every problem that you have now, infrastructure is expensive, you should just move to the cloud. This application is slow, you should break it up into microservices and move to the cloud, right? We've all had this. And like all of you, I've gone through this journey. And this was my experience moving to the cloud. I got burned hard, right? It's easy to get started. I mean, AWS lures you in with the free tier. It's all free to do all of these things until you get that bill shock. And if you're like me, like many other people, you've kind of abandoned a few accounts. Luckily, Jeff Bezos has enough money that he doesn't come after you. But maybe if we learn to manage that a bit, we wouldn't be running away from all the AWS account with those lingering EC2 instances that we've left running. So, like I said, AWS offers many benefits, but it can be very hard to control those costs and identify, that's a typo, identify waste. I'll fix the typo before I send the slide deck to Rian to send out. So in this talk, we're going to try to keep it simple. We're going to keep it very high level. I was saying before we started that the talk is very clickbaity. I submitted the title for the talk when I was busy with Kubernetes at work, and we had managed to create a second cluster and reduce the cost. But I thought it would be a bit more meaningful to kind of cover things at a high level, right? So we're going to cover 3 things, which is setting up yourself for success with AWS, avoiding common architectural waste, and then being proactive about controlling those costs. And then at the end, we're going to have a little Q&A, right? Cool. So let's get started. Setting up yourself for success with AWS, right? It's hard. I'm going to lie to you. It's a very hard thing to do. But when you want to start, there's a code that says you cannot improve what you can't measure. So where you want to start is you want to implement something called AWS organizations and consolidated billing. You want to create, probably want to create separate AWS accounts for dev and for prod, and creating those AWS organizations allows you to manage some of those things, right? So multiple accounts and controlling them as if though they were under one account. You want to create a company tagging policy. It's a very, very important thing for you to be able to identify which things are costing you what cost centers things belong to. You want to create an AWS cost and usage report, and you want to use AWS Cost Explorer for any cost optimizations that you might have, right? So let's talk about organizations, AWS organizations and consolidated billings. So to start off, if you're not using AWS organizations and consolidated billing, and I think I've just said AWS and organizations and consolidated billing so many times, but if you're not using those, you might want to consider implementing the tools, right? Because the organizations enable your team to automate account creation, creating things like groups, and as well as letting those groups reflect like your business needs and, apply governance policies to these groups. So if maybe you're using AWS to automate some marketing things, you want to create something that reflects that, have that separate from your dev, your normal day-to-day, because it kind of just helps you keep track of things, right? The consolidated billing feature within the organizations lets teams consolidate payments for multiple accounts. So you can pay for everything as if though you were using one account. And on the screen is a diagram that shows you what those organizations look like. So, you can create your account, add account, group accounts, and then apply different policies to them. And then you can enable AWS services within that. Cool. The other thing that you really want to look at is usage reports and company tagging policy, right? So tagging enables you to identify, organize, filter, and search for resources within AWS, right? So imagine you haven't taken the first advice, you're not running your dev and your prod workloads in two different environments, you're running everything in one environment. You could have an account that I didn't abandon, but I'm not really using it. So I've been cleaning it up. That's why you see status as inactive there, right? But you might have things like a description or a name for a service or an environment. So, I'm working on an application called Glance, and a name for a specific thing. Let's say, for example, I create like an EC2 instance. I could call it Glance EC2 Dev, right? Or Glance EC2 Prod, and then I can give it, like a key for like the environment. So dev and prod. What that allows me to do, right, is that you can activate tags with cost allocation tagging within AWS. So how much you're spending on your dev resources, how much you're spending on your prod resources, and you also know how much you're spending on those other things. And this comes in handy when you start to look at Cost Explorer. For example, AWS generated cost allocation tags, which you'll see over there. That creates like a very useful tag called AWS created by. It's like a Git blame for the cloud, right? So you can see who created that bucket, who created, you can see who's busy trying to run their side hustle and piggybacking on the company's account, and you can, quickly get on top of things like that. So this is a really, really nice tool. Yeah, that shouldn't be on free tier. It should be on cost allocation tags, and that should be on usage reports. Silly me, sorry. So yeah, I think, when you're preparing to start looking at things, this is another really good one to look at. Cool. And you want to use AWS Cost Explorer for cost optimization, right? So Cost Explorer will show you can break down things like what has been my expenditure per month. You can even have it at a per day level, so you can see how much you're paying for EC2 or RDS on any given day. So when you start to use that, you get things like saving plans and reserved instances, right? And these are cool because like when you plan and you manage your reserve capacity, you can save up to 75% on your hourly rate, right? Compared to the on-demand pricing. So if you know that you've been using kind of the same capacity for the last 6 months, and you're using a T3 small, you can reserve that. And AWS will actually make recommendations on the Cost Explorer for you. And when you purchase this, so you pay upfront for the cost and you get a saving. So you can get a 3-year plan. You can also get like a 1-year plan. You usually lean more towards a 1-year plan, see how that goes. You get some savings. And if you're a bit more confident things are staying stable, then you can up that a bit. Another very good one is the budget configuration screen. So if the company's environment is relatively static, so things are not really changing much, and the team has a good account, like, segmentation. So going back to those tags, then the budgets can be a very helpful resource, but it can, just a warning that it can quickly get complicated with different teams building different features. So, it's something that very good to look at, but also be a bit careful about, not to get trapped in there and suddenly things still don't make sense. Another very good one as housekeeping when you start off is AWS compute optimizer. I think one of the biggest costs in AWS is EC2, right? Because it's the computer. I mean, it backs up so many things. You can have EC2 behind Elastic Beanstalk, EC2 behind EKS, EC2 behind ECS, and a whole lot of host of other things. So within the Cost Explorer, the Compute Optimizer, which is a relatively new tool out of the EC2 area, it's a great resource to identify where you might be wasting some compute resources. So you find sometimes you have an over allocated resources. So you're using like a very large instance when you could do with like a very tiny one, right? And then the last ones there that you might want to look at is config and trusted advisor, right? So the config feature helps like inventory for your resources, and trusted advisor provides recommendations to help you optimize your AWS environment. Like I said, right, Cost Explorer will give you, will tell you that, if you purchase this reserved instances for RDS, this is the amount of money you might be able to save monthly. So that's the first part, right? That's the getting started, making sure that your hygiene is in place. And next, we're going to go more into avoiding the common architectural waste that you might experience within AWS, right? So just about every company has like incurred like technical debt. We've kind of accepted it, right, as part of life. And the result is that we take shortcuts. We take these shortcuts to make sure that we can have more rapid gains. We're agile, we're fast, we're getting things out the door. But what always happens at the end is that some of these choices make sense in the short term, but as we start to scale the business, then things get out of hand, right? So we're going to look at some of those things that you maybe need to be a bit more careful of, right? The first one is snapshots. There's all sorts of different snapshots within AWS, but snapshots are often used as backup storage. And nearly all companies spend money on snapshots, which isn't a problem in itself. But if the team is spending about 10 to 15% of the monthly bill on snapshots, or has snapshots older than 90 days, then suddenly that becomes like an area of concern. In many cases, snapshots costs can build up because there aren't non-functional requirements around backup and recovery, right? So if you have conservative defaults and you've left them in place, or are not, you don't have explicit life cycle policies in place, then costs can easily accumulate. And the application, which was built before 2018, snapshots had to be managed manually, right? But with newer stuff, you can automate some of these things, right? So how can we reduce some of those costs? Like I mentioned, the AWS Data Lifecycle Manager, you don't have to do things manually anymore. You can, change the retention periods on existing snapshots. So if your team has, like I said, snapshots that are older than 90 days, you could consider moving them to a lower cost storage solution, such as the AWS well-architectured framework. The second one is previous gen compute. We know AWS changes fast, right? So it's easy to find yourself running infrastructure that is, still supported, but maybe like not the shiniest thing, right? So if an application or account is spending more than 10% of resources on previous gen hardware, that might be another area for you to remediate, right? So how do we reduce costs for that? If the business can migrate to the current generation hardware, companies can usually see a cost reduction of about 5 to 20%, which is crazy. And I mean, this is simply moving from one type of instance that is older, so moving like from example, like from a T2 to a T3, right? But you need to be careful, right? Because updating an instance can require more effort than anticipated, and the unintended like things that might come up with that, maybe you might need to clean up your support. But this is another like really easy win. Not only do you get to save some money, you also get to win with performance improvements every now and then. Cool. Another one, very like a personal favorite of mine, is the Net Gateway. I had to recently deep dive into this, right? So what is the Net Gateway? So AWS's Net Gateway makes it easy to securely connect to the internet from a private subnet in a VPC, right? Which sounds fancy. It's easy, like just set up a Net Gateway. But you need to know that companies pay for usage hours and for gigabytes passing through the gateway, right? So many people use it because it's a simple managed service. But if a net gateway costs exceed 5% of a feature or an account spend, then that is probably an area for a saving opportunity. So data transfer within AWS is complicated. So this is something worth deep diving. I mean, I could have another talk just focus on net gateway, because this can lead to architectures that have excessive API gateways, right? Gateway charges. But let's look at how to reduce some of that. So some of the things that you want to do, you want to determine what type of data transfers are carrying the most. You need to understand network traffic within your application, within your account. I'll give you an example with us at work. So we run a Kubernetes cluster. So we're running EKS, and we were talking to RDS, which is within AWS itself, but we were talking to it via the internet, because my predecessors had set up that way. So things were sitting in different VPCs. And when we looked at it, we started finding out that things like having those things sitting in different availability zones, sitting in different VPCs were costing us quite a bit. And something as simple as using VPC peering reduced that cost, because things now we're running like internally within AWS. Another thing you want to consider is like, if you've got S3 and DynamoDB traffic, send that through the gateway VPC endpoints instead of the net gateways. Like I said, so nice thing is VPC peering became free, I think late last year or early this year. So you don't have any extra charges there. So it's really, really nice thing to use. And you might want to consider setting up interface VPC endpoints instead of net gateways for other intra AWS traffic. So, if you're talking to RDS, if you're talking to S3, if you're talking to whatever other resources within there, if you set up VPC endpoints, it's a nice cost cutting. But you can't run away from it. For example, at work, we've got Weaveworks that monitors our EKS cluster, and our cluster also talks to the Google Places API, and obviously that is going to go through the internet, so it's going to go through the net gateway. But you can look at those things, and you can consider replacing your net gateway with an internet gateway as well, if it is safe to do so, right? So it comes with a big if. You need to make sure that not all your resources are going through the internet gateway, but some might be safe for you to do, right? Cool. Number 4, I promise this won't be long. There's like 2 more here, then we're going to wrap up soon. Another favorite is AWS S3, right? When people hear S3, they just think storage. This is where I store stuff, and S3 is very cheap, right? But there are actually 3 different cost drivers for S3. The first one being storage, as mentioned. You've got API activity, and you've got data transfer, right? So typically, if you are spending more than 10% of your budget on S3, there may be some areas to optimize, right? So S3 is one of AWS's oldest, most widely used services with broad applications. And these broad applications can lead to S3 being very costly, right? So there are also a number of storage classes that not everyone understands. And the idea of intelligent tiering is fairly new. So while S3 might seem very cheap, there are some things you can look at to reduce some of that cost, right? So first, if storage is driving your S3 cost, you might want to turn on data analytics for that bucket or buckets. That feature comes at a very minimal cost, but after a few days, AWS will make recommendations on how to optimize your tiers, your storage tiers, right? Which is a very, very nice thing. And I mean, almost anyone will have savings there. If your costs are being driven up by API activity or data transfer, And it's a bit harder to diagnose, but you can analyze the activity hitting the bucket and just make sure that the right resources that should be accessing S3 are doing so. If it's just data transfer that's driving up your costs, then you might want to explore things like the cache control headers on the files within your bucket, because oftentimes, like, engineering needs to look at what is causing all the data transfer, and for you to understand that, you might be able to kind of cut some costs there. But you need to be aware, because lifecycle policies, you need to be aware of lifecycle policies that migrate data to AWS Glacier or on rapidly changing transactional data, right? Because those costs alone for just traditional data to Glacier will like basically dwarf cost savings you gain from Glacier's less expensive storage tier. So I know you might have seen everyone just says move to Glacier, but you need to be aware of that. And you need to consider the use cases for your system closely when you're working with S3. While the service is absolutely the lowest cost option for storing data, if you have data that is very transactional and subject to high volume access, then you need to ensure that caching is implemented correctly on your front end, or consider using a managed database like DocumentDB or DynamoDB to serve that same data instead. Cool. Number 5 is AWS's managed services, right? So typically this include CloudTrail, CloudWatch, Amazon Maki, and Config, right? So if your account spend more than 10 to 20% on AWS managed services, then there may be opportunities to optimize, right? So the following 3 causes can cause you to overspend on AWS managed services paired with the steps to address it, right? So for CloudTrail specifically, spending more than a few $100s per month can usually signal waste. You shouldn't be spending that much money, right? So if you need to know that organizations get 1 free trail per account, and after that are charged per trail, right? But in most cases, you only need the 1. So you might want to explore removing any extra ones and just keep the original one and kind of keep it within those limits. That's how you can save some money on CloudTrail. On CloudWatch, this varies per organization. So, some applications that are considered cloud native will spend more on CloudWatch, which, will drive like higher percentages. And like this costs are usually a result of a few expensive logs or something making like excessive calls to the get metric request. So, like you need to look at third-party services, which can also drive the cost up. The solution here involves looking at CloudTrail to identify the problematic actor, and then working with your team to understand what is happening and make sure that nothing that should be making those calls to CloudWatch is making them. And then lastly, if we look at config, the calls there scale based on the number of resources in an account and the rules that you've configured. So this can be higher than people expect, especially for like a very dynamic environments. So config, the nice thing about it is that it's easy to analyze based on the amount the company is paying per month relative to the value config provides. Cool. So last one on these architectural ones is the DNS queries. So, if you're familiar with Route 53, amongst other things, this connects user requests to infrastructure using running on AWS. So if your infrastructure, it could be running Lambdas or whatever, and you'll set up like a gateway, connect that to a DNS to be able to access it from the outside world, right? So what people don't always realize there is that they're paying for DNS queries, right? And while there's no hard and fast symptom here, as costs can range like greatly, as a general rule for me, like companies can optimize if they're spending more than $250 per month on DNS queries. If your costs are running that high, there's probably something you can look at. And there isn't really much that you can do here, outside of working with your team to understand why so many of the requests are being sent to the DNS, and then understanding which of these queries can be optimized, not removed, optimized once you've identified, right? Cool. Then part 3, right? I hope you're not bored. I can hear my sick voice is it's not the best. So I want to sip some of this hot liquid here. Cool. So this last part here, we're just going to talk about like how you can proactively control AWS costs. So in the beginning, we spoke about some housekeeping you need to do in the beginning before you even think about saving costs. Then we spoke about some of the mistakes that you're likely to make with the services, because AWS is very, 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 very tricky. And then in this part, we're just going to talk about like, how to be proactive and some of the things that you can do here, right? And like the short and sweet of it is that you need to embrace AWS cost-conscious engineering, right? AWS is a great resource, but you need to do some work to make sure that you're not being wasteful, right? And you need to be aware that engineers make buying decisions daily, whether by the architectures, by design, or the instances that they start. The only way to control this cost is to empower the engineering team and hold them accountable for the cost, right? Just like they're accountable for performance and security. If you look at the AWS Well Architected Framework, it has a cost optimization section that you can reference, and that's like where you start to keeping your engineers accountable. And one of those things you need to do is linking people, processes, and technology to cost optimization, right? So while AWS cost optimization is a strategy that relies on people, it also relies on processes, and it also relies on technology working together to manage those costs. The people within your organization must be aware of the costs associated with their activities and the solutions they devise. And the process must make recognizing and controlling this cost a key objective, right? So technology must support both the people and the process by providing the information needed to make decisions based on understanding of the associated costs. And this goes back to tagging. This goes back to knowing who created a resource, right? So when you look at the people, these are your engineering teams, embracing the challenge, and the product teams recognizing the non-functional business requirement of cost. When you look at processes, this is building a culture around using standard families or sizes and conservative defaults. And technology, you're looking at like optimizing for the cost metric, right? And it sounds like such an obvious thing, but I've seen things like 1,000 times over allocated, where someone is using like a large instance for a dev thing that could go with like a T3, like small or something like that. The second thing is managing your cloud investment. So companies should be proactive about the investment, not just the cloud costs. So while it's easy to say just move to the cloud, you need to know that change is constant with AWS. Things come out of there so quickly, and organizations always struggle to understand what cost changes are meaningful to focus on. And increasing costs aren't necessarily a problem if the revenue for a product or feature is also increasing with those changes. So it all starts with understanding how much of your features and your product costs. So, like managing things there. 3 things to focus on, like your top 3 causes for tech debt waste is usually idle EC2 instances. So AWS provides a secure and reliable compute capacity in the cloud, which is EC2, but there can be a lot of waste there. Another one where, again, idle instances can be an issue is RDS. RDS is the relational database service. And like EC2, it's one of the most popular services within AWS. Just make sure you don't have any EC2 instances. Someone creates a jump box to be able to access something within a VPC, and then they leave that jump box running for the rest of the year, right? That's money you're spending that you don't need to be spending. Someone creates an RDS instance to test a feature out, and then they stop and abandon it. That's money you shouldn't be wasting. Another very surprising one that is always almost like a hidden cost is unattached EBS volumes, right? So Elastic Block Storage is a service that's commonly used with EC2 for both throughput and transactional intensive workloads, right? With the default config, EBS does not get deleted when an instance is terminated. So you just need to make sure that when you're terminating your instances, you make sure that the EBS volumes are not hanging around, right? And the top 3 causes that driving your AWS cost can be addressed with the following steps. So when you use EC2 Compute Optimizer to right size. So EC2 Compute Optimizer will tell you that you're running an M5 large when you can be running like a T3 medium, and then you can make that adjustment. You can also use CloudWatch to identify like idle EC2 instances, so low CPU, memory, and network. You can use CloudWatch to identify idle RDS, so RDS that has no connections and low CPU. You can use EC2, like CloudWatch to look at EC2 and see what EBS interface to view like the volume state, right? So, but before deleting everything, just please make sure that data is no longer needed. If so, but I also do it like as a careful thing to always make sure that you take snapshots of the data, because then that's a lower cost storage option, right? If you need to restore, you can restore from a snapshot, and use EBS's terminate upon deletion configuration option. The last one that you might want to look at is like adopting the right process and tooling. And this covers engineers, DevOps, and product teams. So as at a technical level, it really comes down to having the necessary process and tooling in place to be able to hold teams accountable. It doesn't matter if you care about all of these things as an individual, but there is no process within your team that enables you to be able to perform some of this, right? So for engineers, you're looking at what is causing the cost of my feature to grow short, right? So that comes with engineers not only understanding how to use AWS, but also understanding how the choices that they make in building their features affects the cost. The second one, which is like a really mostly talked about one, is DevOps. So as ops and customer base grows, our spend, like, we need to look at it. Is it scaling linearly, or are there operational charges that are causing cost to spike, right? And when it comes to the product teams, then you need to inquire about the cost of the products to support marginal analysis, right? Because sometimes you find that a team or product managers are asking for features that will cost you a lot of money, but don't really are not going to generate any money. So when you make them aware of some of these things, then it becomes, oh, actually no, we don't need to be tracking that data in the data warehouse. We can take a snapshot and just look at a very specific period, right? So yeah, creating like a cost-conscious engineering culture and understanding the cost of your features and products is the foundation of actively managing your cloud investment, right? And that starts with providing the right context for the right teams. This is everyone within your team understanding how the choices that they make influence the cost of the product overall. Thank you. Questions?
Why do you only have one meme or emoji in your slides?
I had the emoji with the Coke in the beginning.
Yeah, no, this was awesome, VT. Thanks. Let's open the floor for some questions. I have one or two, but let's hear from other people first.
Cool. Let me just take this to the right screen. I feel like I've been looking
just
down.
While we're doing Q&A, and you can click on that link and just fill out the survey for the lucky draw that we do at the end, where we give away some AWS credits. Okay, who's up for a question? I'm going to go if nobody wants to go, because I'm not sure, VT, how do you move snapshots from EC2? Like, is there an option to just move them to S3 or to archive them?
Yeah, so usually have the ops team doing that. I haven't done them myself, but there should be some material online on how to move it. I know on RDS you can go like this, like really simple click, move this to S3, and then you choose the bucket and move it there.
Rian, if I could maybe ask a question. One of the questions that we had is, controlling the cost of net gateways is quite a complex thing.
Yeah.
And you mentioned sort of identifying what is making use of the NAT gateway. Is that something like making use of VPC flow logs to do analysis?
Yeah,
or that sort of thing?
Yeah, that's exactly it. I know AWS also has an interface where you can do that, like with flow logs, to identify, first of all, like where's your highest traffic coming from. So we recently went through the same exercise, and so we found that the height of our traffic was, again, just talking to RDS. So then we found that, okay, cool, it was easy to just do, because originally RDS was created in the default VPC, and our EKS cluster was in another VPC. We just created like a VPC peering connection, and suddenly like that cost was reduced. Then we started looking again, what's the highest cost, and we found that it was Weave. We found it was Google, and then just going back to the rest of the team and understanding that this traffic coming from Google, what could that be, and is it necessary? Things like that.
Mm-hmm. And I don't know if you've had a look at it, or anybody else maybe on the call that has had experience of maybe trying to centralize network egress through something like Transit Gateway or VPC peering in a smaller deployment. Is that something that somebody's had a look at, and maybe allocating costs for egress across multiple accounts? Because that is the thing that we've been struggling with.
I haven't looked at that. I'll make a note and see if I can look at that. We're constantly looking at ways to try to optimize, so it would be a cool one to look at.
Yeah.
Like, I don't think that you will actually save costs. Like, you still pay between regions, and even between AZs even. So even if you were to send traffic, I mean, you pay for your transit gateways, or if you do the DPCs like VT mentioned, then you don't pay. I think the VPC sharing is free, right, VT?
Yeah, VPC peering was made free, I think, earlier this year. It used to come at a cost as well.
Mm-hmm. But you're still paying for AZ traffic and all of that kind of stuff in any case.
Yeah,
I'm just trying to think.
Especially the cross AZ stuff can also still result in very high costs.
Yeah, I'm just trying to think of like trying to save on that hourly usage cost, because if you deploy a NAT gateway into pretty much every account, that can start racking up costs quite quickly.
Yeah. No, definitely.
One thing that you can also do, what I'm trying to do now, is not to use NATs at all. So Corey Quinn also advocates like NATs are evil, because they just suck. Like, they just suck all of your wallets. But so you can put stuff in the public subnet and then just lock them down as security groups, where, for example, traffic only go to your database if it comes from your application security group, but the application can only receive traffic if it comes from the load balancer. So there's only one flow of traffic that can happen, and you can lock everything down securely like that. And I'm trying to do it like whenever I can. If cost is a problem for client, that's the first thing that I cut on. I move stuff to the public, lock it down with security groups.
That's actually quite an interesting strategy. I work in cloud security, so I get heebie-jeebies just thinking about it. but I do think that there are mitigating factors that you could apply there. Definitely.
It's definitely.
That's an interesting strategy.
Some things you don't assign a public address in the public subnet. So it's in the public subnet, but it can't receive traffic from a public internet. That's one thing that I do usually. So
cool.
We have a question from Henry there. You raised your hand.
Yeah, sorry. Grant beat me to like the $10 million question, right? How do you assign network costs in a multi-account type of situation? But one thing that I really struggle with is kind of having the redundancy with NAT gateways, as well as trying to dissect that cost. So you can have the automation, have one NAT gateway. If it goes down, spin up another NAT gateway and another AZ. But the question is, which way would be the best way to cut that cost? Because NAT gateways cost me per hour as well as egress. and then you still got the inter AZ. So what's the normal recommendation, or what are people doing out there?
Well, just from my experience, like for dev environments, I immediately stand up a NAT instance, but I'm doing like one per environment. So that's NAT instances, and they are much cheaper because it's mostly easy to, but they're not cloud or they're not production ready. So I've tried this and I failed before, but that was like a few years back where I did Transit Gateway. I think I tried VPC sharing as well, but for some reason like there were still D2s back then, and there's this thing called a jumbo packet. Network engineers might know about it, but
Yeah,
that jumbo packet just didn't want to propagate through those connections that I made, and I just gave up after like quite a few hours.
That was one of the problems with VPC peering when it first came out. Yeah.
Exactly. I'm a straight up answer for you. Like maybe somebody else that's on the call, if you have some experience to share with us. Once, going twice. No one.
Cool, thanks. When I get the answer, I'll come back to you guys.
Yeah, perfect.
Yeah, when we get the answer, we'll also send it through your way.
Sure, guys.
So we have a question from Marnus that asks, like, what's your thoughts of FinOps adoption?
I'm not really sure what that is. Is that like DevOps, almost like getting finance closer to dev, or meant to ops?
Exactly. I don't think anybody knows. Marnus, if you want to unmute yourself, like, what do you like? How would you define FinOps? What do they do?
So my understanding of FinOps is the adoption of where you no longer use Cost Explorer, you use a FinOps service or like site, and it records all the costs of multiple environments, multiple accounts, so you have an overall basis of all the accounts costs in Azure, in AWS, in Google Cloud Provider. So one dashboard for all your costs, and even if you have, yeah, that's a basic understanding I have.
Cool.
Well,
Yeah. So I know of quite a few. I'm forgetting the other one. I know there's a tool called I think Cloud Zero. I think they have something. So, but like there's a rise in a lot of these tools because traditionally you'll have these companies that will do your managed services, and now what's coming up is like these tools that connect directly to your account, and you can do things like basically like switch off specific things like purchases for for reserved instances, so kind of you see a bit of a clearer graph. I haven't used a lot of these tools yet because they come at a cost, and I haven't kind of like looked at that yet. But like I know that Cloud Zero is like a cost intelligence tool. I thought you meant more FinOps, as in like just getting your ops people like closer to your finance department, which is a funny story at work. I give a report to, like, we review the like our OPEX cost with the financial director every Tuesday, right? And we look at what we're paying for, and we need to understand, what are the benefits of things that are coming out of there. And we've been using a company that does our managed services called Restack. And I don't know if they have any external tool like that they use, but it's something I'm considering, looking at a few options there. I think AWS is amazing at creating tools, but things are not always so obvious. So when you want to come to things like analyzing your costs across your account or different accounts, using an external tool might actually be best. So I'll be looking into that. And if I find a good answer, I'll send it through to the community page.
Pity, what do you think is some of the best resources that you can use to learn AWS? It's a very more vague question. Just
there's a French guy on Udemy, right?
I know what you're talking about. Yeah, so orange background.
Yeah, I think he has the best AWS courses. He's really good. He goes in depth. I'm a big fan of A Cloud Guru, but it can be quite expensive. If your company is willing to pay for A Cloud Guru, really, really, really like highly recommended. But yeah, it's not cheap. So for me, it's like specifically that French guy. I just need to find his name. I'll log into Udemy and find it. And then it's A Cloud Guru, and then it's WizLabs. So WizLabs is a thing that like allows you to kind of like take mock tests. I use that quite a lot. Even now I'm studying for my certifications because they've expired, and I'm looking at WizLabs to do it. So WizLabs, Udemy, French guy, and A Cloud Guru.
Any other questions? You're welcome to unmute yourself. Networking. Sure. Sure. Doozy will do. Okay, that was a guy's name, Stefan Mariak. Then just like there's a few other tips that I just like that I was thinking of, like while BT was busy, is to like also save you from direct S3 costs. You can put CloudFront in front of that, and then some of your resources will be cached, like some of your items. So if you have a high request rate to get those items, you can bring that down because it will be cached. Then I like also thought about the Glacier, because actually it's a funny story. At one of the companies that I worked at, actually I did this. So I just enabled the Glacier lifecycle policy after 90 days. And I had no idea they actually stored their Elasticsearch backups. And it turned out they stored it in 1 million small files. So come end of the month, we get a huge pull, okay, huge compared to the rest of AWS pool, because S3 then used or like moved all of those 1 million files to Glacier, and then you pay for each one of those files that is moved, and that's quite expensive. So the best thing there would have been to zip them every month and then move that one big zip file over to Glacier. But lessons were learned on that one. And another big one that I see usually is CloudWatch, but the data ingestion. So people just write CloudWatch logs, and then they rack up gigabytes and I've seen terabytes of storage of CloudWatch logs.
People like, so you find like CloudWatch set up with the logs not expiring at all as a start, right? So in most cases, you don't need some of your logs to live beyond like 30 days. And then also just don't log every single thing as debug, like especially if you're running in production, like you don't need to log every single character that comes into your application.